SwayamPrabha. Digital India. Educated India.
Lecture number 13. This is the last processing lecture of thermoset composites. Last class we studied little bit about resin transfer molding, and then we also went quickly browse through vacuum assisted resin transfer molding. In this lecture we will predominantly focus on vacuum impregnated methods. So, this is a very important process wherein which you are looking for high strength, very long size or very large size parts which are used. For example, wind turbine blades are made out of vacuum impregnated methods. The cover frame, the closure for aeroplanes are made out of vacuum impregnation methods. This is very important. Okay. So, we will see this process. So, the content of this process, you will have an introduction, you will have vacuum impregnation methods, you will have vacuum injection methods, you will have vacuum bag molding, then vacuum impregnation method applications, then autoclave process. So, autoclave process is an industrial process wherein which it is used for making complete closure for a Toyota car. Almost all the race cars you design such that you have very minimum drag and very lightweight, they make through autoclaves. So, here what happens is as the name suggests, there has to be a vacuum which is there, then so it is a composite to be made. So, you will have a fiber. So, this fiber is a reinforcing material. So, this reinforcing material, either you add resin to it or you buy it with resin impregnated. So, what we do is, this is the starting material, and in the process you are going to apply vacuum. So, that is what is the entire process. So, you have got the crux of the process. So, vacuum impregnation method, the fiber is wetted with resin and it is assisted by vacuum. Either you buy it from the market as resin infused, or you try to buy the reinforcement from the market, fiber mat, and then you try to reinforce. Based on the vacuum application, the resin penetrates through the reinforcement easily without any air trap. One way is you pour and then you try to sweep it through. When you try to sweep it through, still there is a possibility of having small air bubbles. And what are the problem with these air bubbles? Suppose if you have multi-layer and this air bubble is stuck in between, so then you will never get a sound quality output. So, in order to avoid this, what we do is we try to put the fiber mat and then we try to suck air. So, when you suck air, the possibility of air getting trapped is less. So, that is why we always go for vacuum assisted while pouring the resin. So, the defects of the products are minimized, and then the method used in this mold is vacuum impregnation process, as comparatively cheaper than the compression molding process. In compression molding process, what happens is you should have a capital intensive die, you will have a machine, a energy source to be applied, so that you get a flat surface or a curved surface, whatever you want. Die is expensive, and then die, once you make a die, when you have a batch production, then you can go for a die, batch or a mass. When you have only job shop requirements, not many, 5 parts, 10 parts, then going for compression molding is always expensive. So, this vacuum impregnated process is an alternative for it, and it gives you a sound product after fabrication. So, there are 3 variants of vacuum assisted process. One is vacuum impregnation, one is injection, and the third one is vacuum bag molding. Impregnation, I try to push, that is impregnation, and if I can try pushing through with a lot of force, that is injection molding. Vacuum bag, we will see as and when it goes. What is impregnation? The process which is used for, these are examples I have given, producing circuit breakers tubes that needs wired free structures with good mechanical properties are always done by vacuum impregnation molding. So, here the mold is made out of FRP or cast iron or cast aluminium depending upon the product you make. Okay. The inner surface of the mold are highly polished. So, they are polished with a releasing agent, and they are also polished to give a smooth surface, and releasing agent is also applied. You polish the surface, releasing agent is applied, the mold is closed after placing the reinforcement, and the vacuum is applied, then the resin is sucked inside. So, it is like this vacuum impregnation. So, here you have this is for a mass scale we are talking about. So, this is a pressure vessel wherein which you keep the product, and then this is a resin. Here we are talking about a very large scale. Please do not think a tumbler of resin will be the reservoir. No, we are talking about meter long, or we are talking about bulk production. So, here what happens is, so you have small components which are all arranged, and then there is a reservoir which gets through it. So, there is reservoir wherein which you have all the resin, and you mix the ingredients whatever you want. Components are coated with releasing agent or whatever you want. So, it is done. So, then the reservoir is allowed to move. So, you use air compressor. So, then there is a vacuum which is there. So, this is used for sucking. So, from here it goes through the reservoir, the epoxy or whatever is the reinforced the matrix goes through this, and the excess is collected and it is went out. So, this is a process wherein which vacuum impregnation is done. So, if you want to see, that was a schematic diagram. If you want to see a live product, this is a live product which people use, and then these are the place where the components are done. This is a reservoir wherein which the epoxy or any resin is placed. The topmost part of the mold is connected to a vacuum line through a resin trap. The resin trap prevents any accidents sucking of the resin to the vacuum line. The bottom part of the mold are connected to the reservoir container. So, if you see here, bottom part is connected to the reservoir container, the top part is the vacuum which we are looking at it. During application of vacuum, the resin flows from the bottom. Resin can also flow from the top. If it flows from the top, there is a possibility of air getting trapped or some other defects getting into existence. So, we always suck from the bottom. So, the resin flows from the bottom to the top. Once the mold is completely filled with the resin starts flowing into the resin trap. At this stage, the vacuum line valve is closed and the resin is allowed to cure. And here, as you know very well, I told you, for curing to happen, one is pressure, the other one is temperature. So, you maintain certain temperature, you allow it to do it, or you can also do it at room temperature if you want. So, room temperature slowly cures. If you want to have accelerated curing, you do it. So, this process is called as vacuum impregnation process, wherein which by applying vacuum in this process the resin is impregnated into the preform. In the curing conditions, initial viscosity, gelation time, wettability are the important parameters of the resin which helps in VI. So, we have already studied in the initial, the resin viscosity plays a role, gelation time is over a period of time when does it start curing, and then wettability is the fiber and the polymer trying to attract each other, join each other to form a strong bonding. The matrix distributes the load, the fiber takes the load. If the fiber has to distribute the load, the wettability has to be very good. Other factors to be considered for selection of resin are the service temperature of the part, mechanical properties, chemical resistance and electrical resistance. So, these are all for choosing a proper resin. We have seen enough of resin properties. So, you choose a proper resin to meet out your application. The pot life, the long pot life allows the resin to completely fill the large complex part. What do you mean by large pot life is the gelation, the gelling time does not start, the resin does not cure, the resin is still nascent for a longer period of time such that it could completely wet the reinforcement, so you get the best out of it. So, naturally what do you want, if some resin has to flow through, the viscosity should be as low as possible, but provided you fix in all the other conditions, like a coloring agent has to be added, a filler has to be added, then all these things you have to make sure, make a proper choice and then go for this process. So, this process is called as vacuum impregnated process. The next process is called as vacuum injection molding. So, this process is a combination of vacuum impregnation and resin injection process. This process is also known as hot process. The FRP is used for making the mold. The lower half of the mold is rigid and the upper half is flexible. So, what does it mean? You have a die which is made out of any material, then you put your component here, whatever it is, and then you cover the top fellow with a vacuum bag. What is the advantage? The top fellow die is removed completely. Good advantage. Second thing is, whatever was your shape of the component you want to make, which is guided through a die, the vacuum bag takes that profile. So, that helps you in getting the top surface also the smooth, complete finished part. The lower half of the mold is rigid, as I said, and the upper half is a flexible. So, it can be made out of rubber, it can be made out of a polymer, it can be a bag, whatever it is. The vacuum channel is built around the periphery of the mold for better mold closure outside. The molding process is almost the same as described in VI. So, here what we do is, the vacuum channel is built around the periphery of the mold. So, all around you build a periphery and then you try to maintain a vacuum there. So, this is the heater, vacuum injection molding. This is a cavity, you have a mold cavity, you have a plunger through which the resin is heated. In order to maintain the longer pot life, what we do is we try to heat the resin and maintain it in the liquid state. So, viscosity is less so that it can be done. So, here it is molten plastic is injected into the cavity so that you try to produce a part. So, the catalyzed resin is injected under a pressure of, what is catalyzed? Catalysis, the catalyst is nothing but to accelerate the reaction. Catalyzed resin is injected at a pressure of 0.3 megapascals. It is injected. More than one injection point can also be used if you want to make a large component. So, you will have multiple injection if you want to make a wind blade or if you want to make a closure for a complete car. So, you will have multiple injection points. Location, identifying location for this multiple injection points and the pressure needs lot of simulation studies and then we locate it. In fact, that is really hard. The air trapped in the mold is sucked out by applying vacuum. Good. So, that is what we said, and the flexible top half force of the resin to flow through the reinforcement instead of through the space between the reinforcement and the mold surface. Please understand this point. This is very important. So, the flexible top half forces the resin to flow through the reinforcement instead of flowing through the space between the reinforcement and the mold surface. That means to say, in between the preforms, it is pushing the resin to go rather than going around it. So, the flexible top half forces the resin to flow through the reinforcement instead of through the space between the reinforcement and the mold surface. This is very important. This makes the process different from other process. The resin is injected through until the impregnation happens. The vacuum is maintained till the resin is cured. The vacuum bag molding. This process is used for producing complex parts in smaller numbers. Both large and small parts can be made in this process. For example, I told you aircraft parts, windmill parts can be made and you get a sound product. The products that are fabricated by hand layup process can be consolidated by vacuum mold. See, what happens in hand layup processes, we always have a restriction in the reinforcement. If you are really a very good, efficient, skilled man for making this hand layer process, you can touch up to 60-65% volume fraction very easily. Normally we go around 30%. So, if you want to make 60 or 65 or 70% hand layup process, and then if you are not pretty sure about the quality, it is better we do vacuum bagging and we enhance it. So, generally what we do is, even in a boat hull, we try to make a boat hull, we try to place everything by hand layup process, whatever it is, we place everything by hand layup process, and then what we do is, we try to take a flexible tube and then we push air into it, so that this fellow tries to press, this bag. So, this is the bag. So, this bag is trying to press against the composite. So, this is a die, this is a composite which is made out of hand layer process, and then we apply a bag which is a flexible bag, we apply it, so that this bag tries to apply lot of force on top of this workpiece hand layer process, so that you get a sound product. So, a proper consolidation of hand layer process can be done by this vacuum bag molding process. So, that is what is the advantage. Vacuum bag is a flexible die process. In another case, the products are fabricated using prepegs. What are prepegs? Where resin is already reinforced. So, you just have to place it properly and then you try to get it. So, here it is all the more easy. So, the consolidation will be done by vacuum bag. So, at the present, vacuum bag mold technique is very advanced and it is very sophisticated. You can also maintain you can also control the temperature, pressure to get the required output. So, this is a schematic diagram of vacuum bag molding. So, we have several layers of reinforcement placed, and here is a vacuum which is there, here is a bag which is there on the top. So, the mold is made out of, the mold is a bottom surface which is made out of aluminum, steel, if you want to have multiple process. The polyester film can be used as a releasing agent. The plies are placed on the top and the bottom of the product of the mold. So, the woven fabric of whatever it is you want to keep, you are placing it, is coated with glass fiber, and the peel ply renders the curing laminated surface paintability or bondability with the components. So, these are the steps which are involved. So, the last step is peel ply renders the cured laminate surface paintable. Okay, paintable means you are trying to give a color, or bondable to other components can also be done by this vacuum bag molding process. So, to go more, the separation is based on both sides. It allows volatile material to escape. The separation through the porous or perforated fiber layer usually is done by made out of fluorocarbon polymers. They have separators also applied. The porosity can be reduced drastically. There are bleeder layers wherein which the excess resins are absorbed. So, it is like a cotton, bleeder layer is like cotton wherein which it absorbs the excess resin, so that you get the sound product output. So, you can see here, this is a flexible bag. I gave you an example of a boat. So, this is a flexible bag. If you want, you can have it. So, here is the resin which is the prepeg is completely placed, prepeg or the hand layer process is done, glass fiber is done. So, below this you have a release agent coating will be there. So, you can apply heat for curing whatever it is, and then here is a pump which is used for sucking and then creating vacuum here, and then you apply flexible bag, there also you apply pressure, so that you get the good output. So, the pressure bags are also there. So, you put on top of the pressure bag, you can also try to do it. So, these are the two ways wherein which vacuum bags are used. Pressure bags are applied and then vacuum bag is applied. So, you suck and then try to get a good quality output. Bottom die is there, top you do not have a die. So, you have a flexible bag to get the output. The next process is vacuum impregnation methods. The advantage of VI, vacuum impregnation methods, we have already seen. So, it is economical, it is faster, it is less labor intensive, it produces a smooth surface finish. So, applications, it has been used for large size component, it can be used for pipes. In electrical insulation applications can be made. It can also be used wherever you want to have a good dimensional tolerance you can make, such as a nose cone radome, which is what are the nose cone in the aeroplane, the front portion. This is called as the radomes, front portion of the plane. It is radomes. Nose cones also can be made. So, all these things are made out of vacuum impregnated molding. So, you can make out of polymer based glass fiber reinforced GFRP, you can use CFRP if you want, you can also use Kevlar KFRP, so reinforcement, so that you get the required output. So autoclave is another process which is used. It is an extension of vacuum bag molding process. So here I will show you the process first. So if you see here, so this is vacuum connection already applied, okay. This is vacuum connection already applied. So you have put a bleeder, whatever we studied in vacuum, we have put a bleeder, you have put a releasing film, you have put a peel ply, then you have put a pre-pack, then what you do is this is a bottom die. So you bottom die, you put all as though you are making a normal composite, a releasing agent, then a bleeding agent, then a bag, everything. Then what you do is completely all this, the entire composite on top of this bleeder bag is put with a vacuum bag. This vacuum bag is sealed by a double sealant, so that you make sure there is no leak of air, and then you try to make a vacuum connection. So after making this vacuum connection, the die is completely placed inside a autoclave. So what is there in an autoclave? The autoclave will apply equal pressure and you can maintain a temperature, so that you make sure the consolidation of the workpiece happens to produce a very good output. So very large components are made out of it. Autoclave is nothing but a furnace wherein which pressure, time, temperature can be controlled, so that you get the best out of it. So this is a negative. You can also have positive mold in the sense, if you want to have a component which is made like a U, inverted U, so then your mold becomes something like this, and then you repeat all the process through whatever you make here. That means to say a pre-peg is placed, a bleeder is placed, a pre-peel is placed, a releasing agent is there, a mold becomes a positive mold, and you can put a vacuum so that you get the required output. So now let's go into the process and understand a little bit of the process. It is an extension of vacuum bag process. It is a closed vessel, depending upon the temperature and time. See, generally here for polymer matrix composite, the temperatures and time, the temperatures we always operate is somewhere close to around about 150, 200 maximum, and depending upon a very rare combination of polymer, we can go up to 300, 400. The pressures are generally talked between 1 atmosphere to it can go up to 10 atmosphere or 20 atmosphere, depending upon the consolidation, depending upon your structural use of the polymer matrix composite. Here it is predominantly thermoset. So it is a thermoset process. So you should also make sure that shrinkages, strength, all these things are done. And here in the advantage of autoclave or all these vacuum bags, you are trying to avoid resin rich regions. If you avoid resin rich regions, the weight goes down, the quality enhances. The quality of the product made by autoclave is very good as compared to all other process. The temperature initiates the curing reaction and the pressure aids in consolidation. So I told you pressure, time, temperature plays a very important role in autoclave. Autoclave mold is preferred for aerospace industries, very low production. The pre-pegs, rather than like it is not like making out through hand layup and then going here. Here we always use a pre-peg. So pre-peg is glass, the fiber is reinforced and the matrix is wetted and it is consolidated and kept. So we always try to maintain at a very lower temperature so that it does not cure. Okay. The composites made out of pre-pegs give a very good superior mechanical properties, and it also stringent requirements for aerospace, it is met very easily. During the molding process, the viscosity of the resin decreases. So here it is almost like a ready-made pizza or ready-made item. So it has all the ingredients there. All you have to do is raise it to a certain temperature, make sure the resin tries to change the viscosity, it starts flowing in proper. The low viscous reinforce fills and avoids the any defect. So what is a pre-peg? Pre-peg is a short form of pre-impregnated fiber. So you can have unidirectional, you can have oven roving. So unidirection, it is like you have all the fibers running in one direction, but this cannot independently have. So you stitch this fellow with a small small thread in the, this is warped direction. So you try to do it that 90 degrees, you try to stitch all these fellows. So to only hold them. So those fibers are called as unidirectional fibers. If you want to have the same balance of fiber distribution in the 0 degree as well as in the 90 degree, then it is called as woven roving. Depending upon your requirement, you can choose unidirectional or woven roving and impregnate the presim. So this is available in the market: glass fiber, Kevlar fiber, carbon fiber, you can choose. It is protected on both sides by a removable separator, so that the curing does not happen. It runs like a rim to rim, a reel to reel. So in the reel to reel, what happens? You will have a pre-peg and then you will have a separator sheet on the top. So this is a separator sheet on the top and the bottom. So it is all wound in a reel, so that you can, as and when you want, you cut it and then do it, and then moment you cut it, you can try to orient it any direction depending upon your requirements. So 65% can be easily done with pre-pegs. They are available in tapes and in cloth forms. Usually woven cloths are pre-impregnated, but the woven rovings and CSM are not. Can also be pre-impregnated, but generally we do not do it. So here the uniform fiber to resin ratio, the variation will be as low as 2%. So that means to say you will get a very, very sound product. So they are stored in refrigerator, because when you expose it to temperature it will cure. So they are always maintaining at -18 degrees. They have a shelf life of 6 to 8 months. The moisture consolidation within the chamber must be completely avoided to get a good quality output. This is used for various applications. This I have already discussed. The volatile content should be as minimum as possible, so that while vacuum or temperature application, it should not create a void. So adequate tacking and flexibility is required. I will discuss you little later, and it has a fairly long shelf life. This is what it is. So a molding process, what happens? This I will go to this figure which I have already dealt. So you put the pre-peg. Before the pre-peg, you try to put a small coating at the bottom, releasing agent. Then what you put the pre-peg. Then after that you put a peel ply, right? You put a peel ply. Then you put a releasing film perforation. Then after this releasing film perforation, you try to put a bleeder. So excess resin can travel up to here and get absorbed, and on top of it you try to put a vacuum bag, and this vacuum bag is sealed such that this portion is completely consolidated. Okay. So this is what is dealt in the process. The mold surface is covered by a coating of glass fiber separator, so that it can be removed. The plies are cut from the pre-peg rolls. The releasing film agent is removed, so which is on the top and bottom is removed for the each ply, and it is played. The pre-peg plies are laid in the desired orientation, which we have already discussed. The porous release cloth of a few layers are placed on top, are placed on the pre-peg stack. Then a complete layup is covered with a thin heat resistance vacuum bag, which is placed on a sheet of PTFE coating, which separates it from the cold plate. The entire assembly is transferred into a preheated autoclave to get the consolidation. So today there are companies which make the complete race car body through this. They make a pattern and then they use all these procedures, whatever it is, they make it. So this is as light as possible, and it can be made with very high drag reduction. So the efficiency goes very, very high, and these are all made out of carbon fiber composites. So you can see an autoclave. This is a real time autoclave. You put the component here and then it is moved inside the shell, and then you lock it so that you get the you try to create the necessary pressure and temperature. The curing cycle for epoxy is always done in 2 stages. The first stage, it is increased up to 130 degrees, and the next and it is maintained for 60 minutes. As I told you, the pressure, temperature, time is a very, very important thing in any furnace. So here also it is for epoxy 130, we say. If you add fillers to it, this changes, and the time also changes. During this period, the minimum viscosity is reached. The external pressure is applied on the pre-peg stack, so that the excess resin flows inside the bleeding fabric. So what is a bleeding fabric? You see here, here is a bleeder. So, this is a which tries to, it is like a cotton which absorbs from the blood wound. Cotton is the same way it is used. So, the resin flow is critical since it allows to remove the entrapped and the volatile material from the pre-peg. So, the tools here are very less inexpensive. So, like compared to a compression molding, so here you make a small pattern or a mold or a wood. So, this can be made out of steel, this can be made out of, the pattern can be made out of steel, it can be made out of wood, it can be made out of a composite. People have studied what is the influence of the basic pattern material over the output. So, there are also research, because even a small 1% change, a deviation from the product requirement has a huge influence in the aerospace industry. So, autoclave are used, the tooling is very less expensive, the molds can withstand only the curing conditions. So, that is there. The thermal coefficient of expansion of the composite are to be kept in mind. So, based on that we always go for metallic molds, wooden molds, anything is okay with you. So, we always, while heating, the tool expands. So, that is what we make sure that it should not, the tool expands as compared to that of a layup. Uncured layup can be can deform to that extent of the process. After cooling, the tool shrinks so that it tries to give the output, then final dimensions are reached. So, the tool expansion has a direct influence on the dimension of the product, it is a direct influence. So, this you should make sure you do not, this has to be properly chosen. The pressure exerted by vacuum bag is transmitted to the hand layup so that they can flow. The cowl plate exert pressure on the layup and the excess resin are squeezed out through the layup. So, hence we always use a metal cowl plate, must have very high rigidity in the autoclave process. So, this is a typical cycle of an autoclave. So, you can see that the pressure which is maintained in bar, the temperature is given, this is the time in minutes. So, this is the chamber pressure. So, we always operate up to 1.1 and you can see the temperature going up. So, this is the chamber temperature which is preheat, then you have a compensation time, then you have a duration of sterilization and then you have a cooling period. The temperature is in the sterilization zone. So, this is what it is. So, the temperature initially goes high, maintains it and then you try to get an output. So, heating time, compensation time, you have duration for sterilization, that means to say consolidation, and then you will also try to have a cooling time to get the required output. Because of this autoclave, the process becomes slightly expensive. So, complex parts are only tried to get the output. The parts of the secondary bonding can be economically produced by autoclave by using co-curing process. So, we will see what is curing process little later. Sometimes the operating cost of the autoclave is also can be considerably reduced by curing many parts at a time. That means to say one short process you can do or try to have multiple parts in one autoclave process. So, by that we can try to compensate the price. So, with that we come to an end of this lecture on vacuum impregnated process, which is used for making thermoset polymer metal matrix composite for varying reinforcement like glass, Kevlar, carbon. And here the important process, instrument which we use is called as autoclave, which helps in consolidating and producing a good quality output. So, in autoclave we try to maintain pressure, temperature and time to get a better consolidation. Thank you.